Good morning, students. Today we are going to read alpha, beta, and gamma decays in the topic of radioactivity in the subject of physics O levels. So, this is very important lecture. So, concentrate yourself. Laws of radioactive decay. When an element disintegrates by the emission of an alpha particle, it turns into an element with chemical properties similar to those of an element two places earlier in the periodic table. So concentrate. When an element disintegrates by the emission of the alpha particle, it turns into an element with chemical properties similar to those of an element two places earlier in the periodic table. On the other hand, when an element disintegrates by the emission of the beta particle, it turns into an element with the properties similar to those of the element one place later in the periodic table. So these two are very important points. Next is conservation of the momentum. The principle of the conservation of the momentum applies to nuclear decay. When an alpha particle is emitted in one direction, the nucleus recoils in the opposite direction. So, this is the alpha particle which is emitting in one direction, and this is the nucleus recoils in the opposite direction. If the alpha particle emitted as shown below, then, so this will be the figure. The law of the conservation of the momentum applies to it. Momentum before emission should be equal to momentum after emission. So before emission, m multiplied by 0 because there will be no velocity at all. And after emission, m minus m into small v. So this mass multiplied by velocity plus this mass multiplied by velocity. Because these two are going in opposite direction, so its velocity will be negative. So m into minus v will become minus mv. Shift this minus mv to left side. So m small m capital V will be equal to capital M minus small m into small v, where m is the mass of the original nucleus, this one. Small m is the mass of the alpha particle. Capital V is the velocity of the alpha particle. Small v is the velocity of the residual nucleus. Okay. Next is nuclear reactions. Random decay. Radioactive decay is not affected by the chemical reactions or any change in the physical conditions such as temperature, pressure, electric field, or magnetic field, and so on. Radioactive decays occurs randomly over space and time. In other words, it is impossible to state exactly which nucleus and exactly when a particular nucleus will decay. Alpha, beta, and gamma decay. When the atomic number of an element reaches 82, the repulsion between the protons makes the nucleus unstable and the nucleus tends to break up into smaller parts. When this happens, alpha particles, beta particles, or gamma particles may be emitted from the nucleus. This is called radioactive decay or disintegration. Alpha decay. The general equation of the alpha decay is this one. Here is the original nucleus, And after alpha decay, the proton number will be decreased by 2 and the nucleon number will be decreased by 4, where this is parent nucleide, this is daughter nucleide, and this is an alpha particle. Example is when radium is going into decay through an alpha particle, the proton number will be decreased by 2, the nucleon number will be decreased by 4, and an alpha particle will be emitted. The proton number of the daughter nucleide is equal to that of the parent nucleide decreased by 2. So if this is 88, this will be 86. The nucleon number of the daughter nucleide is equal to that of the parent nucleide decreased by 4. So if this is 226, decreased by 4 will become 222. The proton and nucleon numbers balances on each side of the equation. Like 86 plus 2 will make 88. 222 plus 4 will make 226. So the proton and nucleon numbers balances on each side of the equation. Beta decay. General equation is this one, where ZXA is parent nucleide, Z plus 1 YA is daughter nucleide, and minus 1 E0 is beta particle. In this you can see when a substance decay under beta decay, the proton number is increased by 1. The nucleon number remains same and a beta particle is emitted. Example is here. The proton number of the daughter nucleide is equal to that of the parent nucleide increased by 1. So if this is 84, it will be 85. The daughter nucleide and the parent nucleide have the same nuclear number. So if nuclear number of the parent nucleide is 218, the daughter nucleide will have the same nuclear number if it is undergone a decay of beta decay. The proton and nucleon numbers balances on each side of the equation. Look, 85 minus 1 will be equal to 84. 218 plus 0 will be equal to 218. Gamma decay. General equation is this one. This sign steric indicates that the nucleus is in excited state, where ZAX is parent nucleide on which we are having a steric sign, and steric sign is removed, so this is called daughter nucleide and gamma rays will be emitted. Note, when an alpha particle or beta particle is emitted, the daughter nucleide is usually left in an excited state. It loses its spare energy by emitting gamma rays. The proton and the nucleon numbers do not change. The daughter nucleide is the same element as the parent nucleide under gamma decay. So look here. Now we are going to read some questions. The radioactive isotope, this one, decays to an element radium by alpha emission. So alpha emission. Complete the equation below which represent the nuclear reaction. Under alpha emission, proton number will be decreased by 2. So here will be 88. And nucleon number will be decreased by 4. So here will be 226. And alpha particle will be emitted. So 2, 4. What is the atomic number of radium and the number of the neutrons in it? So atomic number will be 88 of the radium. And second requirement is number of the neutrons in it. So 226 minus 88 will be equal to 138, which will be the number of the neutrons in radium. And other equation is here. The atom of the uranium has an atomic number of 92 and a nuclear number of the 238. Describe briefly the structure of the uranium atom. So atomic number is 92. It means number of the protons in it will be 92, whereas the nuclear number is 238. So the number of the neutrons in nucleus will be 238 minus 92 will be equal to 146. An atom of the uranium consists of a nucleus where there are 92 protons and 146 neutrons. Orbiting the nucleus are 92 electrons. So this is the structure of the uranium atom. Second part is, what are isotopes? The definition of the isotopes is, isotopes are atoms having the same number of the protons but different number of the neutrons in the nucleus. The last part is, why are isotopes of the same element difficult to separate by chemical methods? The answer is, isotopes of the same element have the same chemical properties and are therefore difficult to separate by chemical methods. And other question is here. The unstable nucleus of this emits an alpha particle. So remember carefully, look carefully, alpha particle, and changes to another nuclide osmium, symbol of OS, state the number of the neutrons in the nucleus of platinum. So the reaction will be 78 will be the proton number, 184 will be the neutron number of the parent nuclide, whereas the daughter nuclide will have, because alpha particle is emitted, so proton number will be decreased by 2 and nuclear number will be decreased by 4 and an alpha particle will be emitted. So this will be the equation of the decay, alpha decay. So the requirement is the number of the neutrons in the nucleus of this. So neutrons will be equal to 184 minus 78. So 106 is the answer. B part is the number of the electrons in each atom of this element. The number of the electrons. Okay. Number of the electrons will be equal to number of the protons. So protons are 78. Electrons will also be 78. C part is the number of the protons in the nucleus of an atom of the osmium. So the protons. So protons will be 76 in the atom of osmium. This is the answer. 76. Okay, the last part is the total number of the particles in an atom of the osmium. So in osmium there will be 76 protons, 76 electrons, and neutrons will be equal to 180 minus 76. So sum all these three particles, that will be equal to the number of the total particles. So look now, 76 protons, 76 electrons, and 180 minus 76 neutrons. So add them, that will make 256 total number of the particles. And other question is here. This radioactive atom is a radioactive isotope produced in nuclear reactor. It decays producing a radioactive series. The number of which are, the members of which are, so these are 1, 2, 3, and 4 and 5 elements. What type of the decay, alpha or beta, takes place in each stage? Okay, when this undergoes decay to form this, look, from this to this, the proton number is decreased is increased by 1 and nucleon number remains same, so it means this is beta emission. So beta particle will be here now. When from here to here, so this to this, if you look carefully, the proton number is decreased by 2 and the nucleon number is decreased by 4. So this is an alpha emission. So alpha particle will be emitted. So from NP, okay, from this to this, if you look carefully, the proton number is decreased by 2 and the nucleon number is decreased by 4. So this is also an alpha emission. Alpha particle will be emitted. And from this to this, if you look carefully, the proton number is increased by 1 and nucleon number remains same. So this is beta emission. So beta particle will be emitted. Another question is here. The uranium atom emits an alpha particle to become thorium, which then emit a beta particle to become protactinium. What is the proton number of the protactinium? Okay, when uranium atom emits an alpha particle to become thorium, the proton number will be decreased by 2 and will become 90, and which then emits a beta particle to become protactinium. The proton number of the thorium will increase by 1. So from 90 to increase by 1, that will become 91. So answer will be 91. Look here, this is the answer. Exam tip is the nucleus loses 2 protons after alpha decay and gains 1 proton after beta decay. Okay, next topic in the lecture is background radiation. Our body is receiving a background radiation all the time. Background radiation comes from 2 main sources. It varies from place to place and from time to time. There is a cosmic radiation coming from outer space, and there are radiations coming from the environment. Rock, concrete, or soil may contain traces of radioactive materials. Artificial sources such as X-ray tube and TV may also leak out radiations. Exam tip for you people is the background radiation explains why there is small reading in the GM counter when there is no other radioactive source around. Law of the decay. The law of the radioactive decay states that the rate of the radioactive decay at any instant is proportional to the quantity of the radioactive material present at that instant. So student, this was an important lecture in the topic of the radioactivity. This is one of the very important topic in the subject of the physics O levels. So read this lecture again very carefully and make your notes. Thank you so much, students.